Hi, welcome to a video which I'm aiming at people who are about to walk into AQA GCSE Computer Science Paper 1, maybe tomorrow, maybe later today. I'm going to give an overview of as much as I can of Paper 1 in half an hour, and it will be useful, I hope, as that last minute go before you walk in. If you happen to have more time than half an hour, maybe you're a few days away, maybe you're weeks or months away from your exam, do something else. I've got a playlist which covers this in more detail. I've got other useful videos which I'll link below. But if you are about to do this exam, it's a bit longer than paper 2. It is our programming paper, and you'll have a paper in one of these three languages. This video, I'm not going to show any Python code or C# code or Visual Basic code because I don't want to muddle you if you're doing a different programming language. I'm just going to show pseudocode, but you have got to go in knowing the pseudocode concepts and the different terms in one of these three languages. This paper isn't just about practical programming though, you have got to revise for content, which is what we're going to do in this video. Starting with algorithms. So an algorithm is a sequence of steps that can be followed to complete a task. When we are writing program code, we are implementing an algorithm, and perhaps before we do that, we can also represent algorithms in two other ways. Now, pseudocode is this fairly relaxed version of program code which should be understood by any programmer. AQA have come up with their own version of pseudocode. Now, all of us can write our own pseudocode in different ways, but AQA will have a fairly typical, fairly recognizable version. Flowcharts, there are, I would say, three symbols, which are the most fundamental ones. Start and end will either start or end your algorithm. A process box is a rectangle. You'll write inside the rectangle what is going on. Maybe you are doing some maths. Maybe you are assigning a variable. Input and output could be done in process, or you could do it in a parallelogram. And a choice is for if statements and also for loops. A loop will go back on itself. An if statement will just have yes or no. Again, write a question inside the choice diamond to say what it's doing. Now, algorithms are said to be abstract. Abstraction is the process of removing unnecessary detail from a problem. It's a way of simplifying a problem, but also usually, and if you are a good programmer, you'll utilize decomposition. This is another sort of problem solving technique, it's another way to simplify problems. What this will do is break a problem down into many subproblems that each represent a specific task. So ideally, each subprogram does just one job, and if you solved it, you'd eventually be able to combine all of these solutions to solve the original problem. Trace tables are there to show how values change when an algorithm is carried out. Importantly, you've got to go through every line, so you're tracing through the code line by line. Do not jump ahead, do not guess what it's doing, and only add to a column when that column's value changes. When you move on to a new row in your trace table, do that when you move into a new block in the code. A row in a trace table does not correspond to a line of code. You might have 4 lines of code represented in one row in a trace table. So don't worry about gaps. Gaps are perfectly fine. And if you have got very few gaps, that's also often fine as well. So here is an example bit of code you might get given. You might want to pause and have a quick look through it if you want to. Now here we've got user input being given. And so often the question will give you some values. So don't just jump to the code, read the question carefully in case it tells you things like the values being inputted. Now let's say we're given a blank trace table like this one. It will usually pick the columns for you. It may not represent every variable being used. It can also be items in a list. It can also be outputs, so print statements, which display something to the user. Well, your job is to fill in this if you were given this question. And the first step is, the first 3 lines of code have got 3 variables. Num is set to 0, x is 999, and y is 0. Because they're within one block of code and the order within this isn't important, putting it in one row of a trace table is perfectly fine. But when you move into the for loop, we haven't got a choice because we've not got any space, but you have got to move into a new line because it's a new block of code. So with our first input is 355. 355 is less than x, and so we set x and actually y as well to be none. Now, again, you could put the second 355 on the line below because it's in an if statement below the top if statement. But again, personally, I'd put it on the same row. And we can progress through the code. 554 is the next input. Only this is bigger than y, and so y gets updated. Then 199, this is less than the current value of x, and so x changes. We're left with a gap because nothing happened to X in that section, and so we should really leave a gap to show the sequence of this. If we plugged in 199 above, it would suggest that was changed at the same time Y was changed, which it wasn't, and so some gaps are important for showing the sequence. Let's just progress it on to get the last two values. So outside the for loop, we're outputting X and Y, and so putting that on its own line makes sense. Now, a common follow-up question following a trace table is, well, what is this code doing? And you might be able to spot from the trace table what it's doing if it's confusing, where here we're finding the smallest and biggest item in this sequence. Equally, there might be a logic error which it asks you to try and spot, and the trace table might help you with this. We've got two searching algorithms on this paper, linear search and binary search. A searching algorithm is there to find an item or to see if an item is in a group of items. Linear search is our simplest. Linear search will compare each item in the list one by one until the target item is found or equally not found. Now, crucially, there's no need for the list to be in order to do a linear search. Let's say we're looking for -10 in this list. What linear search would do, start looking at 15, then 17, then 19, then 5, then -10, compares each to our target, -10 is equal to -10, and so this finishes. Binary search is a little bit of a more clever approach. What binary search does is compare the middle item in the list to the target, and assuming the target is not the same as the middle item, it will discard half of the list which can't have the target in. Then it will repeat this essentially, finding the next middle item in that smaller version of the list, and repeats until either you find the target or it runs out of items. Now, this must be sorted. So here's the same version of that list sorted, meaning it's got an order now. And let's say we're looking for 5 in this list this time. First job is to find that middle item, also called the midpoint, also called the pivot. In this case, it's 17. If you have an even numbered list and you can't find a perfect middle, choose either the left of center or right of center, just be consistent. In this case, 5 is less than 17, and so we can discard. You might just cross out the top half of this list. The next middle happens to be 5, what a coincidence, and so we've found our target and it's finished. Regarding how they compare linear and binary search is more time efficient for linear search, meaning as the list grows big, it will on average take less time to find your item. But the key downside is it's got to be ordered beforehand. Not all data is ordered, and so if it's unordered and you can't sort it quickly, linear search is really your only option. The two sorting algorithms are a little bit more involved, and I would argue if you get these as questions can take a bit more time. Bubble sort is a bit of an awkward one to do because what you do is go through the list in what's known as a pass, and you look at each pair, swapping those pairs to put it into order, right? Sorting algorithms put it into order. You can have it with letters, you can have it with numbers. So once you finish the pass, you repeat going back to the start, going through again, and you repeat this whole process until you have a pass happening with no swaps. If you go through the entire list and don't swap anything, it must be sorted. Let's do an example on a very simple alphabetical list. Well, bubble sort would start on this list in our first pass. I would write this out in your workings out, and I would copy the list and personally circle each pair as you go. A and C are in order, so they're left. C and B are not in order, and so I would copy the list down again and swap these two and circle them to show that you're looking at those two. The next two are C and E, which are fine. So now we look at E and D, which are out of order, and so I would swap those. And that is one complete pass. So you've gone from the start, you've got to the end, and in bubble sort, the last item after each pass will be sorted. If the question is mean, you might have several passes to do actually. Here I've designed it so I've only got one more, and this final pass has got to be it going through and making no swaps. Okay, don't forget to do a final pass where it doesn't make any swaps. You could still write it out fully, I haven't here, but you could. The way merge sort works is, first of all, it keeps dividing the list by 2, halving it, until each list has one item only. So if I use the same list, I keep dividing that list by 2, and you'd write it down like this. If you've not got a clean divide, that's fine. You might have an uneven number of items on each side, that's fine. Just keep dividing until you have one item only in these little mini lists. Then the second step is to start to combine these lists 2 at a time, keeping the items in order. So let's now do this in descending order, so going the opposite way around. So C and A would get combined like that. we've got this sort of awkward triplet on the side, so just do it step by step. You've got to kind of leave D on its own for a second, but then combine those in the next step. So the final step will be to combine these two sublists to give us our descending version of the list. Okay, so we're splitting, then merging. That's how merge sort works. And merge sort is a lot more time efficient from bubble sort. It's much quicker on average, especially as the list grows big. But because of all these sublists, it does use more memory overall. Moving on now to the programming side of things, starting with data types. So data type determines how data is stored on a computer and the operations it can do. Now there are 5 ones you've got to know about. They may vary a little bit depending on your particular language. Just on that point, for everything I'm going to show in the next few minutes, in fact the rest of the video really, make sure you know the equivalent in your programming language, because there's one thing knowing AQA pseudocode and another thing knowing how to actually implement it yourself. So I won't comment on all of these. All I would say about characters and strings is we know it is a character or a string because they've got either single or double quotes around it. Here are, I would say, the most important arithmetic operators to memorize. So just on div and mod, because they're slightly harder, real division is just normal division and is a /. So 15 divided by 2 is 7.5. Whereas div is making the result an integer. So it cuts off that fractional part. So 15 div 2 would just be 7. And mod, short for modulus or modulo, gives us the remainder from a division. So 2 goes into 15 7 whole times with 1 left over, which is why 15 mod 2 is 1. You'll use the relational and Boolean operators in your conditions with if statements and while loops. Now, all I'd point out is in AQA pseudocode, 1 equal sign is how you do equal to, whereas in something like Python, you do 2 equal signs for a comparison. And here's an example of how you might use it with and or. So with and, both sides need to be true, and with or, only one side needs to be true for the entire condition to be true. And there are a few different string handling operations. The two to have in your head as you go in, I would say, are substring and concatenation. Substring is giving you part of the string, and they represent this using a subroutine where you give the start index, the end index, and the actual string you're just getting part of. So concatenation is adding 2 strings together, just a plus, but both sides have got to be a string. Now there are lots of definitions for variables, but one I like to go for is this. So a variable is an identifier that holds a value that can be changed. An identifier is just a name we give something. So we give variables identifiers, we also give subroutines identifiers. So here I've got a variable called variable, the identifier is variable. You must have the identifier on the left hand side and the actual value on the right hand side. And we can change it, we can reassign it in the next line, and that's perfectly fine. Whereas a constant is also an identifier which holds a value, but it can't be changed after we set it. And in pseudocode, we'll start with something like constant, and usually we put constants in uppercase letters. Arrows show variable assignment. An equal sign is a test for equality like we just saw, but an arrow assigns a value. And saying it's a constant is an example of declaration. Declaration is setting a certain property. You might declare a variable as global, for example, but equally you might declare a constant. Not every language has constants, so why should they be used? Well, first of all, they help readability. Having pi as a named constant means it's a little bit clearer what's going on, you know what that value is. And also that second point, it makes updating them in the future easier. Now pi won't change, but other common constants like tax rate or maximum capacity, those things might change in the future. And so if you have it as a constant, you just change the value at the very top and it will apply throughout your entire code. And finally, because they just cannot be changed, you might get an error if you try to change it. This reduces the risk of accidental changes, but having a constant locks in that value and so it can't be changed. Now for input and output, like all of this, make sure you can do this in your own language. This is how AQA will show it. Just bear in mind that user input is always a string. So if you are writing program code, don't forget to convert it to either an integer or a real if you are about to do maths operations on it. And we have what are sometimes called 3 fundamental programming constructs: sequence, selection, and iteration. Sequence is our simplest. Sequence is shown on this slide, essentially. A sequence block in programming is where you have 2 or more lines which run just one by one. Whereas selection will deviate, the path will deviate depending on a condition. If statements are how we implement selection in most of our languages. So if statements, the main headline bit is the actual if part of your statement. So one thing to bear in mind is ifs are always checked. So if you've got an if part, this will always be checked, no matter if you have several back to back. So here we've got if price is greater than 30 and if price is greater than or equal to 20. If I had price set to be 50, both premium and standard would be outputted because both are checked. Whereas we often have else ifs or elifs, which sit below an if statement, but these are only checked if previous conditions were false. You can have several else ifs if you want to, just make sure they come after an if. In this case, if I typed in 50 again, only premium would get outputted because the else if wouldn't run. And finally, we can often stick an else on these. Else have no conditions, so nothing comes after else, and they only run if all of the previous parts to this statement were false. Mistakes we see in exams are people adding conditions to else's and also forgetting about else if, and it can lead to logic errors if code runs when it shouldn't really be running. Iteration is our third kind of construct, and these are the loops. And we've got two types of loops, two types of iteration, definite and indefinite. So the one type of loop which is implementing definite iteration is a for loop. So a for loop repeats a set number of times, and that's what definite iteration is. You know how many times it's going to repeat before the loop begins. This is how a for loop looks in pseudocode. It will look similar in your program code. So in AQA pseudocode, you will start with your counter variable, so it's often I. It will start at whatever number you set it to at the start, and it will keep going until whatever number you set it to at the end. Now in AQA pseudocode, that upper number is included, so this code would produce 0 to 5, probably on separate lines actually, but that second number is included, whereas in Python, actually that second number is not included. Use a for loop when you're going a set number of times. If you're not sure how many times to repeat, use indefinite iteration. And we've got two types of loop which implements this. A while loop repeats until a condition is broken, and a repeat until loop repeats until a condition is met. So they're sort of coming at it from different angles. Here's an example of a while loop with a password program. So initially ask the user for a password, and while this password is not equal to 123, it's going to keep asking for the password. Once they type in 123, the loop is going to end. Now, if the user could get it right first time, they might get it wrong a million times. So you can't use a for loop here because you don't know how many times this is going to repeat. Here is a repeat until loop, and you can kind of see two differences first of all. The first difference is what I said in this definition, that it repeats until a condition is met. So here the condition, password equals 123, is opposite to the while loop. But the second key difference is the condition comes after the loop. So a repeat until loop always runs at least once. And so you don't need to have that kind of outer input line like you do with a while loop. There are two data structures to know about. A data structure is an organized collection of items. By far the most commonly used one is an array. So an array will typically just contain items of the same data type. So this first line here, scores is set to, then these items are part of this array. And we use square brackets to signal that it is an array. And you can see all of these are integers. So you group multiple items under one name. This is quite efficient. It means you can do things like indexing. Now indexing is where you are specifying a particular item within an array. So this second line where I'm going output scores index 2, well, that's specifying the number 92 here, because you need to assume that indexing starts counting at 0 unless you are told otherwise. So 3 is in the 0th position, 53 is in the first position, 92 is in our second position, despite being the third item. So always start counting from 0 and always use square brackets to index. You can also, overwrite items like I've done in this third line. This is changing 13 to be now 5. Now, because we're using arrays to group similar items, often we want to iterate through these items, and you should be using a for loop for this process. And the for loop will always look very similar. So we start counting at 0 because of our first item having the index 0 most often, and we end with the size of our array -1. It's -1 in pseudocode at least because we start counting at 0. Then you just output it by indexing using I as your variable. And if I run this, having changed index 4 to be 5, it will just show the items like this. Now arrays can get a tiny bit more complicated because you can have 2D arrays as well, which I think scare people quite a lot sometimes, but really an array, which is 2D, is just an array of arrays. So you've got mini arrays inside a bigger array. So if you've got two sets of square brackets, that's a sign you've got a 2D array. And it's not too much more complicated because all you need to do is use a second index number. Now, it does get a bit more complicated when you are wanting to iterate through it, admittedly. This looks a bit nastier than the previous for loop I showed. But again, the structure is always very, very similar. So if you are asked to iterate through a 2D array, it will look something along these lines. So it's a for loop inside another for loop. And if you look at this middle line, so output scores index I, index j, that's what I mean when I say you index using two numbers. Okay, the first number is the sort of which array is it. So if I was 0 here, that's referring to the 3 and 53 array. Whereas if I was 1, that's referring to the 92, 40, 13 array. The second number kind of dives deeper and goes inside the particular array you're looking at. So if you can learn this structure, that would be useful. This would again just print out all the numbers so you get all of them. Now just as a quick bit of terminology, here we've got a for loop inside another for loop. This is an example of nesting. Nesting is where you just have one block inside another block. So if you've got, say, an if statement inside a while loop, that's also an example of nesting. The second data structure, which is less common, but just to be aware of and don't get thrown by it if you see it, are records. So a record, instead of using index numbers, will use named fields to organize the items. So here's how you might set up a record with two fields. Name is a field, age is a field, and you give it a data type in this definition. Now this isn't the actual structure itself. You need to actually create the data structure for this record. So I'm setting user as my record, and I'm setting AJ to be the name and 16 to be the age. So those are the values for my fields. Then I can just use these field names instead of indexing it to get the particular values. So user.age in this case would be 16. Moving on to subroutines. So subroutines are named out of line blocks of code. Here is an example subroutine. It's a block of code and it has a name. So add is the name in this particular subroutine. And out of line refers to the fact that often we define these right at the top of our program, and to actually run it, you have to call it. So calling it is just saying its name in your main program. So if I extend this code to call this subroutine, well, output welcome is just saying welcome, but saying add 10, 15, this is me calling the subroutine. And what it means is it will jump up and run the subroutine code. When I run this entire program, it will just say welcome from that welcome line, and then it will say 25 because 10 plus 15 is 25, and that is what this subroutine is doing. So num1 becomes 10, num2 becomes 15, and it's going, well, num1 plus num2, so 10 plus 15 is 25, then it's going to output 25, and so that's why I see it on my screen. So it jumps up, and what we call the parameters are the placeholders for the actual values I put in at the bottom. Now the actual values are sometimes called the arguments, but if you described 10 and 15 as parameters, that would be okay. You can have one parameter, you can have two, you can have 5, you can have 10, you can have 0. So if you've got empty brackets, that means you don't put any numbers in, you've got no parameters. And parameters are just special kind of variables used for input to subroutines. Now the reason we use subroutines is because they can be easily reused. All you need to do is define the code once, and to reuse it again and again, you just call it with one line. So you've got less repeated code, which leads to fewer mistakes. You writing the same codes again and again, it leads to mistakes and errors, and also programs are easier to test if you've got nice blocks of code which you can look at individually. And just as a general principle, if you are decomposing into subroutines, this makes it just easier to code because you're solving simpler problems at a time, and it's especially useful in a team because separate team members could program separate subroutines and they don't really affect each other. So parameters are one bit of terminology we've got to know about. We've also got a few others. So as you may have spotted, the code is morphed, and I've now got a return line instead of an output line. So this is what we call a return value. You might hear these described as functions, whereas what we had before is called a procedure sometimes. So now I've got a return value. This does slightly change how I call, because a return value is sort of given back to your main code privately it's not shown to the user. And so what I've done here is I've assigned this return value to a variable called result, and then outputted a result in the next line. So I still get welcome 25 shown, it's just done in a slightly different way. Okay, so if you've got a return value, make sure you actually assign it to a variable in your main program, and then print that if you need to print it. So we've got several variables in this code. Num1, num2 are, like I say, special kind of variables called parameters. They're kind of separate. But we've got sum and we've got result, which are two standard variables. The difference is sum is an example of a local variable, whereas result is an example of a global variable. A local variable is assigned inside a subroutine, whereas a global one is assigned outside of it. Local variables only exist while the subroutine is executing. As soon as add finishes, sum ceases to exist. It's not around anymore. And so because of this, really, they're only accessible, only available inside the subroutine. I couldn't print or output sum after add is finished because it doesn't exist anymore. Whereas global variables are available anywhere in your code. Now there is a programming style which is very much connected to this, called structured programming. This is an approach which produces, or is trying to produce, readable, so clear programs, and organized programs by doing a few different things. First of all, this approach recommends you do use decomposition, and you decompose problems into modules. A module being a block of code, and in essence this is saying, look, make subroutines, because they're nice individual blocks. Other aspects are you need to be using clear parameters, so you're recommended to use parameters, and also recommended to use return values. Sometimes the parameters and the returns, because they're the input and output to a subroutine, they're sometimes called the interface of the subroutine. A more simple one is use of meaningful names, so making sure things like add and sum and result are sensible, are meaningful. And the big one is trying to minimize use of global variables. So actually you having loads of global variables is not a great thing to do. If you've got global variables, because they are available throughout the entire program, their name, their identifier, can't be easily reused. Right? Words like sum and result could be used lots of times in a big program. With it being global, you can't just reuse it because it's going to change the value. Whereas sum, you could use the word sum in loads of different subroutines and they wouldn't affect each other. And also if you've got global variables, it can occasionally lead to mistakes. Somebody might try and change their version of result and it might change another programmer's version of result, leading to quite confusing errors. There are two types of error to know. A syntax error is an error where you're not following the rules of the language. You miss off a colon, you add an extra bracket when you shouldn't do, and so it means your code won't even run. Whereas a logic error, the code will run, it's just the result is unexpected, it doesn't do what you intend, there is some mistake somewhere. Validation is where you are enforcing some rule around user input, usually to try and avoid errors actually. So for instance, you might use a while loop to ensure that the user types something in and they don't type in just nothing. So often while loops are used for validation. Actually also used for authentication too. This is where you're checking the identity of a user, so most often password or username checkers. And in order to make sure your program is robust, meaning it won't break because of errors, you should use a different range of test data. So you should try some normal test data, which is what you are expecting to get entered. Boundary test data is sort of like either side of the boundary. It might be acceptable, it might not be acceptable, but it's close. Whereas erroneous is completely wrong and probably would break your program if you didn't validate it. And the last thing I'll end on is just some quick advice for some of the trickier questions where you've got to write a program in your program code. Do not write pseudocode here, it's got to be code in the language you have studied. Tiny mistakes aren't penalised, but it has got to be in that language. Now, people get put off because these can be quite a lot of marks. Do the basics no matter what. So you get marks for assigning variables, for casting if it's a number, for using things like while loops, if statements, even if they're not totally right. Be guided by the question, do read the entire question before starting. Take some time to think about what it's asking for, think about what construct is needed. If it says things like keep asking, use a while loop. If it says things like check to see, use an if statement, etc. And the bullet points often tell you the rough order to go in. There'll be grid lines which are there to help you indent. You can see I've indented inside my while loop just by shifting my writing across into the next box. And don't get too put off by the size of your answer grid or the number of marks available, especially early on in the paper. You might get quite a few marks for not much writing and you might get loads of space to answer it in. Use this as a guide, especially towards the end of your paper. If it is an 8 marker, that suggests you're going to need to use a loop, maybe an if statement, maybe a couple of loops actually. And that's it. I really hope paper 1 goes well, and you'll be back ready for paper 2 when it comes around.